Hello, my name is PaybackTime5 and here I am going to show you my 8-bit Redstone computer that I made. Now before we start running any programs on this, specifically the Fibonacci sequence, I want to show you how this all works. First off, we have the display. This just takes 8-bit numbers and converts them to base 10, which is then displayed on these 7-digit displays here. We have the ALU back here, which does all the arithmetic. We come back over here, we have the RAM cells, which store data, and while they write data onto them, they read the data, and then they can also clear the data. Over here, we have the program line and program counter. In this area here is the user interface. We have the clock and all the other things you can do, such as clear the ALU, clear the RAM, update the display, turn it on, clock once, and select your programs here. Now, one thing I would like to mention is that there is an ample use of pistons. If you get triggered by use of pistons in computers, then this channel is definitely not for you. Now, obviously, I don't like to use pistons a lot in these builds because they can cause problems. But if it's just something for like the display, I honestly think that pistons in the display look pretty cool. You can see like parts moving, and I think that's just really neat, especially with the display. Just really for looks over there. Then you have monstrosities like this, which is just pretty much just laziness, I would say. Because, just using pistons with sign blocks like this is just the easiest way to move a redstone signal down. And obviously there's like a billion different ways I could have done this, but yeah, I chose pistons. Here I kind of ran out of space. I mean, I could have just like looped these lines all the way back, had them run all the way down, but just using pistons here would just like save on some speed and allow me to run the clock at higher speeds. This build actually used to have a lot more pistons than what it does now. This used to be pistons, and it would take pistons there and to these things right here until I realized that that was just plain stupid, and I was just that really was the height of laziness. But besides that, let's go into the program. So this is the program line, say numbers 0 through 15. And when you turn on the computer, you start on program line 0, which doesn't have anything written for it. That's because this entire line is reserved for the program selector. So when I turn on the Fibonacci, it signals it to move from program line 0 to program line 1, which is where the beginning of the Fibonacci program is stored. So as you can see, these torches, all these torches do is show which line of program I want to go on. So when you select the Fibonacci, it goes on to line 2, and then from line 2, it goes on to line 3, and then from line 3, it goes on to line 4, then to 5, then to 6, and then finally at 6, it loops back to line 4, I believe. No, 5. It loops back to line 5. No, wait, no, line 3. I'm dumb. So this line right here. And on each of these program lines, we can come down here. This is where the rest of the program is stored. Basically, this tells what the computer to do. So it's kind of hard to see it here, but I have a little sheet right next to me. I'll explain to you what it does. So when it goes to program line 2, it signals it to input 1 into the main line, which is this line right here. So inputs 1, which would be, I think it's this line right here. Then it stores that line in ALUB. So if you come over to the ALU, you can see that there is 2 memory cell registers here. One for ALUA, one for ALUB, and what the program tells it to do is just to save 1 to ALUB. Then the next program line just simply tells the computer to input 1 onto the computer and go to the next line. Then when it goes to the next line, it says input that number into ALUA, display that number, and then read the number from the RAM over here. So one thing I just realized I overlooked is also on line 1. It says to write the number 1 to the RAM. So on this program line here, it just simply says to read the number that was written onto the RAM. And that would be 1. Then the next line says to write onto the RAM here and add the number from ALUB and what is on an ALUA. After that, it jumps to the next line. It says read what is on the RAM, so what we just wrote from the addition, display that, and input the number to ALUB. Then the next line says to add both numbers from ALUB and ALUA and write that number and then loop back to line 3, or as in this case, line 4. So now I'm going to show you how you can turn on this computer, and simply you flick the on switch, you flick the clock, so this tick clock back here, clock is running, however it has nowhere to go because it's on line 0, so it's not like it's jumping to any of the other lines. However, when I tell it to go to line 2, it goes to line 2 and then the program starts running. Now the maximum number this thing can go up to running the Fibonacci sequence is 233. So if we just let this run for a while, it will eventually get up to 233, and then after that it will overflow and just start displaying random garbage numbers. One thing to notice is that this program selection is I kind of just made it up. I didn't follow any designs or anything. I just kind of like made it on my own. So it's definitely not ideal. But I had trouble finding anything about program selectors on YouTube or anywhere else. Of course, it didn't really look that hard. So I'm sure I could find a better design than that. Besides that, the display, the whole display area was, it just jumped to 233. So as you can see now, it's displaying random garbage numbers. So let's just turn off this computer. To turn it off, all you need to do is turn it off, clock once, turn off the clock, clear RAM, clear ALU, update display, and just clock once again. So went back to 0. So this display design, at least the 7-segment display, and this part right here were designed by Matt Batwings, and the ALU right here was designed by Nubasaurus. Besides that, this whole computer design here is just basically just an upscaled version of a computer made by The Darkness. His computer though was a 4-bit computer, so I guess I can say this is kind of just an upgraded version of his. I did actually build that 4-bit computer that he made from the tutorial. That's the first computer I made, but I won't be making a video of that because I think that if you wanted to see that computer, you should just go check out his channel. So if I just go up here, you maybe notice that this kind of layout here is similar to the Darkness's. With all that being said, there is obviously a lot more that I need to learn about Redstone computing, there's a whole myriad of functions that I could be using, but I'm not. One thing though is if you guys have any ideas for programs I could try to run or try to make a computer that could run, I would greatly appreciate to see those in the comments. So I could eventually make a computer that could run them or run them on this computer. With all that being said, I've got nothing left to show you on this computer, though there are some other projects I'm working on. For example, there is this shulker box memory system for a ROM, and some note block machines over here that run off of binary memory. But these are by no means even close to finished. But they're just some things to look forward to. So, with everything here being said, I will see you soon, but this is goodbye. Tschüss.